In the previous videos, we understood how we can calculate the square root of large numbers with even number of digits. In this video, we will solve the square root of a large number with odd number of digits. Take the number 24,649. We will follow the same steps we studied in our previous video. First, we draw two lines like these, one on top of the number and one to its left. Make sure you leave some gap between the number and the line on top. Now we are ready to follow our steps. The first step is to mark pairs from the unit's end. By pairs I mean combination of two digits. The unit's digit in this number is 9, so we start marking pairs from the right hand side. So 49 will be one of the pairs, and then 46 will be another pair. But wait, we can't see any pair that's left. There is only one digit that's left. In this case, we just mark a dot above the digit 2. There is nothing different about this single digit that we have here. It will be treated in the same way as the other pairs. If you get confused with single digits, another way you can look at this is by assuming 2 as 02, which will be a pair of digits. Anyway, coming back to our step, we marked pairs from the unit's end. We split the number into three parts: 2, 46 and 49. In the second step, we look for a perfect square which is closest and just lower than the first part, which in our case is 2. Think about it. Closest and just lower perfect square. 1 squared is 1 and 2 squared is 4. Since 4 is larger than 2, the perfect square closest and lower than 2 is 1. Let's strike this out as we won't need it. Once we find this perfect square, we write its square root here to the left of the number. And the square root of 1 also happens to be 1. So we write a 1 here. That completes our second step. We found the perfect square and wrote the square root here. In the third step, we multiply above and add below. When I say multiply and add, I mean we multiply and add the same digit. So let's multiply above first. 1 multiplied by 1 gives us 1. We multiplied above and wrote the product here, right under 2. Now let's add the number to itself below. So 1 plus 1 gives us 2. Don't forget to leave some space here. This space here is left for the box. We draw a small box here, big enough to fit in one digit. That completes the third step. In the first step, we marked pairs and split the number into three parts: 2, 46 and 49. Then we found the square closest and lower to the first part, which is 2, and then we wrote the square root of the perfect square here. Then we multiplied above and wrote the product here, and added below to write the sum here. The first three steps are generally a little tricky, but the next three steps compensate for it by being very simple. In the fourth step, we just subtract the product from the number above it. The product is 1 and the number above it is 2. So we subtract 1 from 2 and get a 1 here. That completes our fourth step. The fifth step asks us to get the next pair down. The next pair is 46. We get 46 down and write it next to the number 1. The sixth step asks us to draw the same box above and below. A box above and one below. As I said, the fourth, fifth and the sixth steps are really simple. We subtracted 1 from 2, we got the next pair down, and we drew the same box above and below. Now we come to the most interesting step of this long division method. We have to find the digit in these boxes. If you remember correctly, the digit in all these three boxes will be the same. We find the digit by trial and error. Basically, we just try out a few things and finalize our digit. Now we want the product of two numbers equal to or just lower than 146. The product should look something like this since we have a number 2 with a box here. This product should give us the number closest or just lower than 146. Let's try out 25 multiplied by 5 first. these two digits will be the same as the digit in the boxes will be the same. This product gives us 125. It doesn't look close to 146. Now let's try 26 multiplied by 6. This product gives us 156. Technically, 156 is closer, but wait, we have to choose the product which is the closest and lower to 146. So the product we are looking for is 125. And the digit in the boxes will be 5. Remember, the 7th step and the 2nd step are the only tricky ones in these. Actually, they are the most interesting ones. Others are methodical steps where we don't really need to apply our brains. After we find the digit, we go back to the 3rd step. We multiply above and write the product here. 25 multiplied by 5 gives us 125. Next, we add below and draw a box next to the sum. 25 plus 5 gives us 30, and we draw a box next to it. In the next step, we have to subtract the product from the number above it. The product we got this time is 125. Subtracting 125 from 146, we get 21. We can see that 125 is 21 less than 146. But that is as close as we could get to 146. Anyway, in the next step, we get the next pair down. The next pair we have in the number is 49. So we get 49 down, and that gives us the number 2149. After this, we draw the same box above and below. Now we need to find the digit in these 3 boxes by trial and error. Think about it. We want the product of two numbers equal to 2149. Since there are no more pairs left, we can use the trick we studied in the last video. The units digit of 2149 is 9. So the product will either be 303 multiplied by 3 or 307 multiplied by 7. Why do I say this? Look at these two pairs of numbers. 3 multiplied by 3 will give us 9, and even 7 multiplied by 7 will give us 9. There is no other single digit whose product with itself will result in the units digit as 9. So let's find these two products. 303 multiplied by 3 gives us 909, and 307 multiplied by 7 gives us 2149. That's it. This is exactly what we wanted. The product as 2149. So the digit we wanted is 7. And as we did previously, after finding the digit, we go back to the 3rd step. We multiply above and write the product here. 307 multiplied by 7 gives us 2149. Then we add below. 307 plus 7 gives us 314. We don't leave place for a box here since it was the last pair we were dealing with. And in the next step, we subtract the product from the number above it. Subtracting 2149 from 2149 gives us 0. And that's where we stop. Don't forget, the square root of the number is the number here on top. Hence, we get the square root of 24,649 as 157. And one way to check your answer is by looking at the number here. If this number is double of this number, then your answer is correct. In the next video, we will use the same steps to find the square root of 73,441. If you have understood the steps, then I would recommend you to solve this example in your notebook and verify your answer by seeing the next video.